Good morning, students. Today we are discussing the another separating process, that means sublimation. Okay, we have discussed already up to magnetic separation. Here now open to page number 34 in your book and see sublimation process. Okay, now what is the definition of sublimation? Sublimation means of what? You all know sublimation is a transition of a substance directly from the solid phase to the gas phase without passing through the intermediate liquid phase. Is this clear? Okay, so sublimation means what? It also converts from solid to gas without passing through the intermediate liquid phase. Okay, so there are two type of compounds present: sublimable compounds and non-sublimable compounds or solids. Okay, so sublimable solid means those solids which on heating directly convert into gaseous state without entering into the liquid states are called sublimable solids. And non-sublimable solid means remains such as, okay, examples of solid that sublimates on heating are camphor, ammonium chloride and iodine. And non-sublimable solid means what? Which are enters in the liquid state. So non-sublimable solid, that means the sodium you can say sodium chloride, magnesium chloride. Okay, these salts are the examples of the non-sublimable solid. Now technique: the mixture of sublimable and non-sublimable particles are heated in an evaporating dish covered with a funnel. See this dish, see this image, this dish is called as a evaporating dish. Okay, covered with a funnel plugged at one end with cotton. See this end position, and here see this is cotton is also present. Plug this cotton, okay, inside this funnel and in position of this funnel. Okay, on heating the sublimable solid sublimes and its vapors condense and collect in the pure form on the inner side of the funnel. Is this clear? The non-sublimable solid remains behind in the evaporating dish. Okay, so example: separation of ammonium chloride from mixture of ammonium chloride and sodium chloride. Now one question arises from here: how will you separate, or how to separate ammonium chloride from the mixture of ammonium chloride and sodium chloride? Okay, let's see how does it work. So first of all, see, take a china dish containing this one is china dish, or you can say as a evaporating dish. Okay, take a china dish containing a mixture of ammonium chloride and sodium chloride and heat this over a Bunsen burner. This burner is called Bunsen burner. Take a glass funnel. Okay, this one is called glass funnel. Take a glass funnel, plug the tip of the funnel using a cotton ball. See, this is a cotton ball. Okay, cover the china dish with glass funnel. Okay, white fumes evolved from the china dish after heating and rise the funnel. Okay, white fumes evolves out from the china dish and rise in the funnel. Then you remove the funnel from the china dish when the white fumes stop rising. Okay, you remove the funnel from the china dish when the white fumes stop rising. Okay, after cooling, remove the solid NH4Cl, that means solid ammonium chloride, sticking on the walls of the glass funnel. Okay, that means so ammonium chloride has also sticked the walls of this wall of the glass funnel. Okay, now you use a spatula and transfer this solid, okay, stick solid which are already present the wall of this wall of this glass funnel. Okay, use the spatula and transfer it to the another watch glass. Okay. Now remaining solid, that means remaining solid in china dish is NaCl. This process is called sublimation. We also use we are using this process, we use this process, and we also separate the NH4Cl from the mixture of ammonium chloride and sodium chloride. Okay, this is very easy process. Now the another process is evaporation. Okay, evaporation. See, principle. First of all, principle. Okay. It is based on evaporation of liquid component from solid liquid mixture. Okay, it is based on evaporation of liquid components from solid liquid mixture. Solid liquid mixture means what? If you have taken any salt solution, that means NaCl mixed in water. Okay, this becomes as a solid liquid mixture. Now technique. The soluble solid can be separated from the liquid component by allowing the liquid component to evaporate on heating. During the process of evaporation, the liquid component disappears in the atmosphere and the solid component is left behind in the evaporating dish. See, first of all, this dish you can say as a evaporating dish, like that. Okay, you can take any beaker in place of this dish. Okay, now question comes like that. Question arises like that. First of all, how to separate common salt from salt solution. Salt solution means what? Salts are added in water. Okay, how to separate common salt? Common salt means NaCl, sodium chloride. So first of all, we have taken salt solution in China dish. This dish we have taken the salt solution in China dish. Oh, one thing, all the images or all the diagrams you will draw. Okay, all the images are or all the diagrams are important. Now see, we have taken salt solution in a China dish. Heat this solution over the Bunsen burner. This one is a Bunsen burner. Okay, after some time we will see that the boiling has started. Boiling means what? Boiling of this solution has started, as well as evaporation has also started. Okay, if boiling has started means what? Evaporation has also started, because this is open container, na? Okay, now during the process of evaporation, water disappears slowly in the atmosphere and NaCl is left behind in this China dish. Then after using this process, you will separate the common salt from the salt solution. Very easy process. Okay, now the another process is, turn over the next page, move to the next page, and then another process is distillation. Okay, distillation means what? Distillation, or you can say this is the simple distillation principle. It is based on the distillation of liquid components in a soluble solid liquid mixture. Okay, in a soluble solid liquid mixture. Technique. Distillation, what is the definition of distillation? Distillation is a process of converting liquid into vapors and then condensing the vapors back into the liquid. Okay, this method is useful to separate the solute and the solvent from a solution. You all know solute and solvent means what? If you have taken a salt solution, salt used as a solute and water used as a solvent, that means lesser amount present in solution means what? Solute, and larger amount or higher amount any substances is present in solution, that means this is called solvent. Okay, to get distilled water, set up an apparatus as shown figure 3.11. see, this one are the setup of apparatus for distillation. Okay, wait, we'll discuss. First of all, we have taken some example. Distillation of impure water, a sea water to get impure water in laboratory. So in this process, the question will be how to separate potassium permanganate. This is the color of potassium permanganate solution. Okay, how to separate potassium permanganate and pure water from solution. In this case, we'll use the simple distillation method. Okay, now first of all, take a amount of potassium permanganate and water in a distillation flask. See, this round bottom flask we can say as a distillation flask. Okay, so what is a distillation flask? This one, this round bottom flask we consider as a distillation flask. So take the solution of water. Take a mixture of potassium permanganate and water in this flask, distillation flask. Okay, put a thermometer in it. See, this is the thermometer. Okay, put a thermometer in it. Why? Because we measure the temperature, okay, of the solution. We measure the temperature of the solution. Now put the thermometer in it. The third point is connect the flask to a water condenser. Okay, connect the flask. See, this is the flask, and this one is called water condenser. Connect the flask to a water condenser, and you can say the water condenser is a Liebig's condenser. Okay, this is the Liebig's condenser. See, here is two hole. One hole is used for the water inside, water comes inside, and another hole water comes outside. Okay, then the condenser has cold water. See, this condenser has cold water running through its jacket. See, this one is called also, these two holes you can say also jacket. Okay, through its jacket to keep the temperature cool. Okay, now keep a beaker, or you can use conical flask. Keep a beaker or you can use conical flask at the outlet of the condenser. This is the outlet position of the condenser now. Okay, so outlet of the condenser. Next, you heat this mixture. Okay, you heat this mixture or you heat the mixture, but you can also keep your eye on the thermometer. Okay, heat the mixture keeping an eye on the thermometer. Okay, you must be observe the temperature also. Okay, when the temperature hits 100 degrees centigrade, that means water start to vaporize. These vapor condense in the water condenser. See, first of all, water start vaporize. That means the vapors of the water comes through this funnel. See, this, the not funnel, this tube. Okay, you can say as a delivery tube. Then it comes this tube, and in presence of this condenser, it becomes cool. The vapor of water becomes cool, and it becomes liquid. From the vapor phase, it becomes liquid. Okay, now this vapor condense in the water condenser. The condensed water, this condensed water gets collected in this beaker or in this conical flask. Is this clear? When all the water vaporized from here, when all the water vaporized from this round bottom flask, or you can say as a distillation flask, KMnO4 or potassium permanganate left in this distillation flask. Okay, now we have collected the all of the water from the solution into this conical flask. In this way, KMnO4 or KMnO4 means potassium permanganate and water gets separated by simple distillation method. Okay, this is very easy. You will draw this picture also. Okay, and okay, you also draw this picture. Then you write down the process. How to write down the question also, how to separate potassium permanganate and pure water from solution. Okay, now the next process is very easy process, sedimentation and decantation. Okay, sedimentation you have already read in class 7 na? Sedimentation and decantation. See, principle, it is based on settle down of insoluble solid particles by gravity, that means gravitational force, in an insoluble solid liquid mixture on keeping in undisturbed for some time. See, what will be the examples of insoluble solid and liquid mixture? Sand, water. Okay, sand, water, stone, water. Stone means very finely divided stone. Okay, sand, water. Now, technique. The insoluble solid components in the insoluble solid component in the solid liquid mixture settle down on keeping it undisturbed in a beaker. This process is called sedimentation. The liquid collects above the settled insoluble solid particles is poured out. The process of pouring out the liquid such that the solid remains behind is called decantation. See, first of all, you have taken a beaker and take this solution. Solution means sand in presence of water. Okay, the solution of, this is actually not solution, you can say solution of sand and water, or insoluble solid and liquid. Okay, now after uh, after some time, no, for some time you must be settle down this solution. Okay, solution means this sand and water, sand in presence of water. Okay, after some time you can see, you also observe that sand particles are remaining remaining left just below of this beaker, and water are present the upper portion of this sand. Okay, now you pour out the water, you use the another beaker and pour the all of this, pouring out the all of the solution, all of the water into this beaker. Okay, then this process is called sedimentation. When you pour out the water from from this beaker to the another beaker, this process is called sedimentation. And the solids means what, the sand particles remains behind or remains left in this beaker, this process is called decantation. Okay, this is very easy. Now example, the sedimentation of impurities in drinking water. Is this clear? So we have already discussed all of the the four, not all, only four separating topics today, separation technique today. Next class we will discuss the another four methods. Okay, separating methods. Thank you.